right, let's, for another example of multivariate analysis of variance, let's look on page, we're still in the Green Falcon book. Look at the bottom of page 230. And this scenario goes through question number 4 on the next page, about a fourth of the way down page 231. So if you would call up and follow along in your Hymnals lesson 28 exercise file 1. Looks like this. I think that's actually on the screen right now. So lesson 28 exercise file 1. And what we're doing is, if you look at that second paragraph, we're evaluating the effects of conflict resolution training. So conflict resolution training is the independent variable. That is the group. 3 different kinds of conflict resolution training. And it tells you that 1 is cognitive based, 2 is behavioral based, and the third is the control group, no formal instruction one way or the other. And then to measure the effects, we're measuring the effects 3 different ways. So those are my dependent variables. So for each of the 3 groups, we've got 3 different effects being measured as outcome. Some score on something called the social problem-solving inventory. That's the SPSI column. And then the rating scales compiled by the teachers, that's the rating of teachers, and then the rating scales compiled by the parents, that's the rate underscore P for parent. So the instrument score, the teacher rating, and the parent rating, those are my outcomes. 3 different kinds of conflict resolution training, 3 different outcomes. The group is 1, 2, 3. The outcomes are the last 3 columns that you see in front of you. So to analyze this, we're going to go question.
So compared to the other ones we had,
This has 3 dependent variables, as opposed to the last example where we just had 2. So this one has 3, which is going to be important in just a minute. So to analyze, general linear model, multivariate because more than 1 dependent variable. Click that, and I've got a window with boxes, the big box to the left and several smaller boxes to the right. The fixed factor is only 1. That's my independent variable, the type of conflict resolution training they have. The other 3 are outcomes or dependent variables. Social problem is a dependent variable. Teacher rating is a dependent variable. Parent rating is a dependent variable. So get everything in the right box. Okay, we're going to go to options. Everybody caught up with me? Okay, so we're going to go to options. And we're going to move everything over for group. There's only option on that option. And we're going to ask for descriptive statistics, which is means and standard deviations for all the groups and all the results in all the groups. We're going to ask for effect size, and we're going to ask for homogeneity tests. But down here for the significance level, because we have 3 dependent variables, we're going to divide 0.05 by 3. And if we do that, we're going to get something like 0.01666666. I'm going to round that down and just say, because I think I can only use 3 digits, 0.016, because I want to make sure my significant level is low enough to be kind of on the safe side. If we say something significant, it's more likely that it is. So I'm going to look at 0.016 for the significance level. If you put 0.17, it's probably not going to make much difference. I don't think the results change any in this case. Yeah, I just truncated after the 3 places. 0.17 is okay. I'm just going to play it a little more conservatively. So I'm going to click OK. We're going to ask for post-hoc. Again, group is the only thing I can move over. And because we're dividing our initial significance level by something, in this case the number of dependent variables, I'm going to ask for the Bonferroni method of follow-up. Who has no what? Oh. That's funny because I'm sitting in with my iPod, which is usually the thing that works least well. I'm getting at least one report that says the room's not working. Is anybody else? Or tell me if you can get in the room or not. Because I'm actually able to get in and work at this time, but. Because mine actually works, which usually I can tell is not. Okay, I'm getting reports that it's okay on other people's end, so you may just have to follow up with the recording if you're. Sorry about that. Somebody else having trouble too, I'm told. So at least a couple people are. Okay, Keith, you're saying you can't see the SPSS. If it's showing up on I know it'll show up on the recording. There may be a local connectivity problem, so yeah. So I've got some problems from at least two of you, and hopefully the recording will work. So just bear with me till we finish the problem, and hopefully it'll be clear when I send you the URL later. Okay, so on the follow-up test, the post-hoc test, we're dividing that by group, and we're using Bonferroni, so I'm ready to continue. And I think we're okay to get an output window. So I'm going to click OK and get an output window. And under the descriptive statistics right here, that's where I'm going to get my means and standard deviations that I'll report in that table. And you can write this one up if you want to. This is where you get the means and standard deviations to report in the table at the end of the write-up. And again, remember, I've got up to 3 paragraphs to write narratively. The first paragraph is based on, at great risk I'm going to write on this, the Wilks lambda. So for the Wilks lambda, I'm looking at really all these numbers. F of 6 and 50 degrees of freedom respectively. That F value is 11.517, or 52 if you want to round it off. The p-value, this says 0, but I can't say 0 less than 0.001. That tells me it's significant. That means I've got something that's significant from something in some group somewhere. Eta squared is 0.5. Does that look like 580? Yeah, 0.58. So there's my first paragraph for my write-up. There is significance, so I've got to go on. I've got to continue. There it is. Okay. So, for the second paragraph, I'm going to go back to the test of between subject effect, and I'm going to look at the group and error parts. And I've got three things to report on. I've got to report because I had three dependent variables, or three outcomes. I'm going to look at social problem solving inventory, the teacher ratings, and the parent ratings. And I'm going to have to, I don't have much room, so I'm going to have to just kind of do this one at a time here. Let me see if the best way to do that is. Give myself a little room to do that. There we go. So for the social problem solving inventory, again, we're reporting this in the second paragraph. I'm going to use the F value of 2 and 27 degrees of freedom. This 2 by social problems for group, and this 27 by social problems for error. They all happen to be the same, but that's not always going to be the case. They're all going to be 2 and 27 at this point, but that's just because it works out that way here, because we had everything was equal size-wise. That F value was 22.518. The p-value is less than 0.001, so that's significant. What are we shooting for here, remember? Yeah, we're looking for it to be less than 0.016. Well, if you get a bunch of zeros, it's going to be no matter what you've got. But to keep in mind that we had to divide that 0.05 by 3 dependent variables. And finally, my eta squared is equal to 0.625. So you talk about 62.5% of the variance being related to the group. So that means we've got to follow up on SPSI. So just remember that, because I don't have room to leave it up here, because I'm going to write it now. I'm going to talk about teacher ratings. I think we'll call that ratings of teachers. So again, F value of 2 and 27 degrees of freedom. That F value is 24.307. The p-value, significant. Great, we got to follow up on at least 2 things now. Oh boy. And then the eta squared is 0.643. So you talk about 64% of the variance. So far we've got to follow up on social problem and follow up on teacher. Yeah, sorry, Gil, I may have written off the page there, but it was the number in that last column on the Wilkes Lambda line. Okay, so follow up on the first 2 outcomes. Let's see what we need to do with the third outcome. So again, the same 2 parts. This time looking at parents' rating. So that was rate underscore parent, I think. F value here is for, again, 2 and 27 degrees of freedom. This 2 and this 27. F value is 36.817. P-value less than 0.001. Eta squared 0.732. And I'm probably writing off the page of that again too. So I've got to follow up on all 3 of the dependent variables. So that means I've got a heck of a third paragraph to write. That's okay, we can do it. Scroll down to the multiple comparisons. all significant, I want all parts of it. So for social problem solving inventory, I want to compare cognitive to behavior, cognitive to no training, and behavior to no training. The ones I didn't connect are just the same information. Teacher ratings were significant, so I want to compare within teacher ratings, I want to compare cognitive to behavior, cognitive to no training, and behavior to no training. Parent ratings were significant, so I want to compare everything within the parent ratings. Cognitive to behavior, cognitive to no training, and behavior to no training. Now, when I look at my significance line, let's not forget something. What do we have to do here? We have to divide the 0.016. By what? By 3, because there are 3 groups within everything. So we're looking at approximately a point, if I'm dividing this right, 0.005 as our line in the sand. Did I do that in math right? Okay. Okay, so for the significance we want the ones where I've connected the dots. This one, 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 this one. So which of those are below 0.005? The very first one? Yes. The very second one? Yes. So within social problem, cognitive and behavior are significantly different. Cognitive and no training significantly different. But behavior and no training are not. So for the social problem solving inventory, we're going to say cognitive is different than the other two. And you'll have to look back at your means and say if that's higher or lower than the other two. Cognitive is different from behavior right here. Cognitive is different from no training right here. Cognitive is not different, behavior is not different from no training here because, again, we're looking at the 0.005 line in the sand. Wouldn't be anyway. Okay, for teacher training, yes, yes, and no. Same thing for teacher training. Oh, there's something you could say together. So you could say for both social problem and teacher ratings, cognitive was significantly different than the other two. But looking at parents' ratings. They're all the groups are different from each other in parent ratings. So for our third paragraph, we're going to report that for both social problem solving inventory and teacher ratings, the cognitive-based group is significantly different from both the behavior-based group and the no training group. Same thing here for social problem as it is here for teacher training. However, in the parent ratings, all 3 groups are significantly different from each other. And every time you say there's a significant difference, you need to make sure you indicate which are higher and which are lower. When looking at parent ratings, all 3 groups are different from each other because I get below, below, and below. That's the third paragraph. And final paragraph. Yeah, to find out if they're higher or lower, just go back to the means of standard deviation, which you're going to make the chart out of anyway, for the very last thing in the write-up. We'll do the graph real quick. Sure you do, because we're having so much fun. For the graph. We go to legacy dialogues. I think I can remember this. Box plots. Clustered and separate, I think, is what we wanted to do. Isn't that what we picked last time? Is that what the book said to do? Clustered and summaries of separate variables. Category axis is again, it only fits one way. There's a single independent variable here. The others are what the boxes represent. So the boxes represent the three dependent variables in this case. The category. By the way, if you had like 17 dependent variables, I guess this would let you expand and keep going. I don't know. We won't do that many, but I guess theoretically you could. But so if I click OK, I should be able to get an output window that gives me that box plot for each of the three groups. See, now I've got three sets of comparisons for each of the three groups. Well, remember in the note, look at the parent ratings, the one where everything was different than everything. Those are the ones kind of in the grayish, the sort of light brownish. Here's the parent ratings for cognitive group. Here's the parent ratings for behavior base. Here's the parent ratings for no treatment. These are all different from each other. Now keep in mind, the box plot that doesn't give you the means and standard is based on the median and quartile. It's a little bit different data. But it's still a pretty good illustration in this case that everything, the midpoint or where it identifies what the middle is of those light brown boxes, they're all different from each other because that was the case for the parents. Those are the parent ratings. In social problem inventory, remember it was behavior was different from, no, what was it? Was it cognitive different than both? Yeah. Oh, sorry, teacher, yeah, okay, yeah, same thing, you're right. Well, I've been talking about teacher then. Yeah, teacher is different than, the cognitive is different than both. Here's the teacher cognitive, here's the teacher behavior, here's the teacher no training. That, looks like this green is a lot higher than either of the other two greens. And that's what we said, is significantly different, or in this case higher, than both the other two groups. There was not a significant difference in the teacher ratings between behavior and no training, and that's kind of what it looks like here. So this green isn't a lot different from this green. Other thoughts, questions, comments?
Your outside line, your bracket, that's your
No, again, these are based on quartiles and medians rather than means and standard deviations. Yeah, I think if you chose error bars, I think error bars use means and standard deviations, which you can do either for your dissertation, but this is the way they take us through it here. Well, you can't tell from just the picture, but the picture does illustrate what the numbers mean. I would hypothesize that this left green box is probably higher than the other two green boxes, and it is. But it's kind of hard to tell sometimes because you just can't tell visually if something is significantly higher or not. But this gives a good picture of what the numbers mean. That's what it's supposed to do. What else? Okay, you've got an APA write-up to do, and you can use this one if you want, or you can use the one that's going to be your homework problem, which is lesson 28, exercise 2. That's going to be the last half of what's on page 231 in your Green and Salkin book. So homework is lesson 28, exercise 2. The data from that, and you can write up that for your write-up if you want to, or you can write up this one for your write-up if you want to. Everybody equally unhappy. The data set we're looking at right now is lesson 28, exercise 1. That's the one we just did on the screen. Homework will be same lesson, lesson 28, but exercise file 2. Okay, is that enough for now? Want more of the 5 O's, or we need to digest a little bit? Okay, so you know what's what and what's the next thing for you to do. All right.